All right, well, we are closing in on the end of the class here. We've got 2 weeks left of instructions, class instruction, and then we have dead week and finals week. And so we're going to go over chapter 10 here. As I said on Thursday, this week of chapter 10 is about service department cost allocations. So we're going to go over examples from the book. I'll put them into Excel. So you'll have workable Excel functions there in Canvas. And then we'll also go over problems, which follow very similar ideas. So let's talk about the direct method. The short answer is that the direct method ignores interdependency. So the idea here is, the first idea, just to go over one more time, the idea of service department cost allocations is you're trying to assign responsibility to the appropriate parties. And you have these production departments that are actually producing the things you sell. And they are almost always run by profit managers, meaning that the decisions made by the manager of production department affects both the cost and the revenues of the firm, or of that locus, of that subsection of the firm. But they don't do that work alone. They pull from different service departments to get some work done. Otherwise, they couldn't do what they want. They couldn't achieve this profit without some of the costs from these service departments, which are cost centers. And so the managers of the service departments are cost center managers. And that word should be here too. Profit center managers. So that's why we're doing all of this. The problem becomes when you have multiple service departments and there's interdependency among the service departments, and then it gets a little hairy as to how much of the service department's cost is given out to each of the production managers, because there's not going to be one production manager. There are multiple of them, most likely, or in many firms. And so they have to figure out a rationale that balances all the different needs that you have. All right, so the first method is the direct method, and the direct method says we're going to ignore interdependency. So this table represents specifically these 10, 12 cells represent interdependency. So let's rebuild this raw data. Let's rebuild this spreadsheet basically here in Excel. So we have service department 1, service department 2. Nope. 2. And we have their cost. We have SD1 and SD2 again. Now we have production department A and production department B. So the idea is this is the consumption of services. These four right here. How much does service department 1 consume of service department 1's? Nothing. How much does service department 1 consume of its own services? That doesn't really make any sense. How much does service department 2 consume of service department 1's services? Looks like 20% of service department 1's work goes to serving its other fellow service department. And then 35% of its work is serving production department A, and 45% of its work is serving production department B. Just as a check figure, of course, it sums to 100%. All right, service department 2 here serves service department 1 with 35% of its work. So this is going to be, I'm putting it in percents here. This table has it in percents. I think there are a few problems that have you do this step to get it to percents, where you're saying there's some cost driver that we're measuring, and this amount of cost drivers traced to service department 1, this amount of cost drivers to production department A, this amount of cost drivers to production department B, and so you have to transfer that into percents. So if there were 100 units of cost driver that service department 2 served that were due to service department 1's work, and then the overall amount out of all the work they do is 1,000, then this would be 10%. 100 for service department 1 out of 1,000, 10%. All right, nice and easy. Okay, I'm copying over 0.5 0.6 here, 60% of Service Department 2's work is for Production Department A, and 5% of its work is for Production Department B. So check figure, make sure I copy everything over right. Yeah, good. Okay, and the costs, $100,000 and $500,000. So Service Department 1 accumulates $100,000 of cost. Service Department 2 accumulates $500,000 of cost. We're trying to figure out where those go. Direct method says, let's simply ignore any interdependency. We're going to zero this out. Act like it doesn't exist. It never happened. The service departments are not serving each other at all. Instead, we're going to have to recalibrate now. No, copy. We're going to have to recalibrate now how much work is done to Production Department A and Department B. Out of the existing work, how much was for Production Department A, how much was for Production Department B? We acted like any of the cost driver units we served, Service Department 1 served to Service Department 2, never happened. So they're not in the denominator either anymore. So this check figure illustrates this. We no longer have 100% of our work. We have 80% of the work accounted for. We've got to change this percent to make this back into 100%. So what I'm going to do is I'm going to say, all right, 35% of the work done, and we only act as if the work done to production departments was done. See what I did? I took that 35% and said, I only care about 35% out of the total of production department work, which was 80% of the work done. So now I have a new percent. I do the same thing here. The 45% of work done, when we're talking about all 100%. But I'm going to now divide it out of only the work that counts, which is work done for production department, over the sum of these two. So now I have 56.25%. So that's just like in the textbook right here. All right, I can copy those down. Should work just fine. And I did some rounding. You can see this extends on, but it rounds to 92.31%, just like in the textbook here. And this is 7.69% right here. Okay, and now we've got the check figure back up to 100%. Okay, so one more time through those steps. We're going to ignore. We're going to act like there's no interdependency. That's direct method. We don't want any of this business. We're going to pretend like it didn't happen. The only thing that happened is service done from service departments to production departments. And so what we have to do is we have to say, well, if that's the denominator, just the work done for production departments, we need to get new percentages, because at the end of the day, we need this to be 100% because we're going to take 100% of this cost and push it to production departments. Give responsibility for it to production departments, to the profit center managers. So we need new percents that will lead to 100% of this cost being allocated to those production department managers. Okay, nice numerator, denominator game right there. It's really that simple. In fact, I'm fine going over this example because it's very much what each of the problems looks like 2 service departments, 2 production departments. This table's very often there in the test. So this is a good rep as a result. So now this is the allocation phase. We're gonna take these percents and turn them into, sorry, I read that cell. Allocation phase is the next thing. We're gonna take these percents and turn them into dollar amounts. So I want this dollar amount times that percent. So if I'm taking 43.75% of the $100,000 of Service Department 1's costs and allocating them to Production Department A, that means I'm going to be allocating $43,750. Nice and easy there. I'm going to change some absolute. I want the absolute column, so it'll stay. And then I can just go right and down. And that should work. Yeah, same idea. I want the percent that Service Department 2 served to Production Department A times the $500,000 of Service Department 2's costs. And so now it looks like Production Department A is receiving $461,538.50. That's 46 cents. There we go. That's the rounding, which is just matches here from Service Department 2. And we can sum those. So the corporate allocations, it's literally a journal entry, or effectively is just a journal entry. We're debiting production department A a total here of $505,000. We're crediting these service departments. Service department 1, 43.7K. Service department 2, 461.5K. Doesn't exactly balance because I did weird rounding, but we really are moving those costs in the books. So then, if you filter out the right entries, you will have then production department A's cost with all the costs incurred by the manager there within the department, as well as the costs incurred elsewhere in the firm because of that manager's decisions. So you have helped assign responsibility for costs to that manager so that manager can be appropriately evaluated and incentivized and improved and fired or promoted or whatever. Okay. This check figure worked pretty well too, because we summed and said, look, we pushed out 100% of the costs we started with these debits. So at the end of the day, once this entry is done, once the corporate allocation entry is done, the service department should have $0 left from their costs. And if you're trying to evaluate the cost center manager, you simply evaluate the costs before you have that entry. So you filter out that entry when you're looking at the inside their accounting system, and it'll have all the costs before the corporate allocation entry. And then you say, oh, well, is that a really high cost for an accounting manager? Or is that a really low cost for an accounting manager? Are you doing a good job managing your costs? And then you can evaluate the cost center manager for his or her decisions that are within his or her purview. Make him or her responsible for the decision rights that have been delegated to him or her. All right. That's the direct method. Let's do a problem. One direct method problem, and then we want to jump over to the step-down method. I want to make sure we get to both those today. All right. I want that. Not that one either. All right. So using the direct method, how much is Department B's allocation to Department Y? So I like to either mentally or literally make sure I am saying who is allocating to who. So I want to know how much B is pushing to Y, how much B is allocated to Y, B's costs allocated to Y. So B is one of the service departments, it's the maintenance department, and Y is one of our production departments right here. So all I really need to know, I can take this table, which has a lot of similarities to this right here. I don't have the cost column into the table. I have it written out in text right down here. And like I said, there's some cost drivers. So in this case, departments A and B, their work is measured by the kilowatt hours for the power department, 100 kilowatt hours to Department B, 250 to Department X, 150 consumed by Department Y. And Department B is through labor hours. So 200 labor hours consumed by Department A, the other service departments, and then 80 and 120 by X and Y, respectively. So let's see if I can copy over. Play nice. Yes, it plays nice. Okay, good. So I don't know how much B is going to allocate to Y. I need to get this into a percentage form. We start, just as an example, looks like we have a total of 400 total labor hours. So 120 is less than 50% of that if we did this right now. But the direct method says, wait, we got to start by ignoring any interdependency. No service departments serving each other. We're going to act like that doesn't happen. So if we go back and we say, well, let's zero that out, our new denominator is 200. So 120 labor hours consumed by Y out of 200 hours that count gives us 60%. So 60% of the work that counts, which is only work done to production departments, 60% of that work was done for Y, Department Y. So we can simply take the Department B's costs, 100,000, just right from here, and multiply them by that 60%. So Department B should be allocating Department Y $60,000. Yep. Good. I'm going to highlight here in case you look at this spreadsheet in Canvas. I changed that. I zeroed out. I'll do that too, just for completeness. I zeroed out the interdependency, so that these denominators still work. Or they are only the countable work done, the work that was done for production departments. Okay, you create the whole table this way. Department X, 40% of the work that counts, the 200 labor hours that count, was done for Department X. 60.5% of the work that counts, Department A did for Department X. 37.5 is what Department A did for Department Y of the work that counts. Okay, I only care about those three, so I'll highlight those. But yeah, you can recreate these four sections right here, and these four cells can be percentagized right here in these four. Okay? Sorry, if it made sense before I went on a little tangent there, just don't worry, the tangent didn't add anything to you that you missed. The good news is, I mean, if you have it solid in your mind, that doesn't take too long. That's a few steps. Pretty quick to calculate that. You don't have to copy. If you know what you're looking for, I could simply say, okay, B to Y. B serves Y, 120 out of what counts? Looks like 200. So 120 over 200, I do that math in a calculator or on Excel, and I'd get 60%. And then I think just by looking, you can tell 60% of 100K is going to be 60,000. So at one point, you have to do some math. 120 over 200. If you don't want to do that in your head, which I wouldn't blame you. I don't think I would trust myself necessarily. Okay. The hallmarks of the direct method. So there are a few conceptual questions on the quiz. The hallmarks of the direct method are that it is the simplest. But the downside is that it is the least accurate. Because you've taken all the interdependency and ignored it. So if we go back to this example right here, there's something going on with these percentages. And it was intentional, but I think it reflects real distortions that could happen in the firm. Service Department 2 really only almost exclusively serves, of the production departments, Service Department A. Once you get to these percentages, which is out of production department work, how much is done for A versus B, you get to 92% of that $500,000 is getting pushed to production department A. But if you look at the percentages overall, which I pointed to first, but just look at them now overall, it's not 92% of work being done. It's 60% of the work being done. There's a lot of extra work being pushed to production department A because we've ignored the work Service Department 2 does for Service Department 1. And that 35% of the 500,000, if we traced the money all the way through, would go to Service Department 1, and Service Department 1's work is much more evenly spread. In fact, it has more on Production Department B. So I bet if we somehow incorporated the interdependency, Department A would get hosed much less. And it would be more accurate, a more accurate reflection of how much cost really is due to the decisions made by Production Department A's supervisor and Production Department B's supervisor. So the accuracy is low, and I bet Production Department A's supervisor is going to say, wait, I don't like this, and might petition or favor, at the very least, a different method. So if we're going to move upwards in accuracy, we're also going to at the same time be moving downwards in simplicity and ease. Step-down method almost always takes an additional step or two. All right, so step-down method says, well, we want to incorporate some of the interdependency. Let's try and incorporate the big interdependencies that really matter. But that means that we're going to have to ignore others, because we don't want to be doing this forever. We want it to be a simple process, as simple as we can make it, that we can algorithmically pass through. And when it's done, we still have the same end result, which is that we have moved all of the debit expenses from the service departments to production departments. So that the result of this, the result of those parameters I just set out, is the step-down method, where you take, first thing you do is you take your service departments and you rank them in terms of importance to be stepped down. Typically this is done, or this makes the most sense logically and economically, to say which service department serves other service departments the most, and it's the top step. And then you go one by one down till you get to the service department that serves the other service departments the least. And then you are really hitting the bulk of the interdependency. You're hitting as much as you can with a linear process that's going to go through each service department's allocation once and be done and have zeros in the balance for each of those service departments at the end of the day. So there are a few rules from this. The first rule is every department, every service department is allocating to every production department and to every downstep service department. The other rule is you cannot allocate to upstep service departments, which is implied in the first rule, but just to make it explicit. So the illustration shows exactly what's happening. So the first step you would take with the blue arrows, which will show up in a second again, service department 1 would allocate to all of the production departments, which happens in every case, every allocation, and always to production departments, and to the service departments that are downstep. Then service department 2 here allocates to the three production departments and the one service department that's downstep. And finally, the last service department allocates just to production departments. Now that should sound familiar, because that's what we did just a second ago in the direct method. In every situation, we use step-down method. The bottom step service department does the same thing as what we just did in the direct method. It ignores any interdependency because every other service department is up step. So there's no chance for interdependency. It's going to ignore it. And we're going to do a modified version of exactly what we did before. So service department 1, I look at it as a modified version of what we did before. I'll say that. Maybe you won't quite see it that way. But let's go ahead and recreate this example. I use the same initial setup, so we can copy that over. Let's put some labels in here. This is the direct method example from textbook. This is the step down method example from textbook. All right, so we have the same idea, and we're going to say, service department 2 serves service department 1 more than the opposite, the vice versa. So we're going to put service department 2 as the up step. Now, the question will tell you which one gets allocated first, or which one's the top step, or whatever. It'll just tell you. You don't have to say, oh, well, I've got to evaluate how much each to serve. That's not an issue here. In fact, firms, for a variety of reasons, may set up their step down a different way than having the most interdependent first. They're free to do that. They might have good or bad reasons for doing it differently. So we have first allocation here. I'll call it top step allocation. But same thing, it's the first allocation we're doing. And so what we're going to do is we're going to say we're going to take this step that we did right here, all right, this right here, where we multiplied the cost by the percentages without having changed any percentages. Because the top step, it gets to allocate to everyone below it. Okay. SD2. It's got that 5,000. And it's going to allocate to all the departments that still count, that are below it, which includes both production departments. It always includes the production departments and the downstep service department. Okay, so that 500,000 gets 175,000 of it is going to be moved to the other service department. And now, instead of us pushing 461,000 from service department 1 to production department A, we are moving 300,000. Production department A manager just thanked us. Okay, just as a check figure, we can sum this, make sure it equals 500,000. Yep, we allocated all the costs. All right, so that top step one is done. Now let's move down step. And the illustration in the textbook has 3 service departments, and in practice you'll have lots of service departments, but each question in the exam has 2. So there's a top and a bottom step, just to get you in the general procedure. Okay. Now, here is where sometimes we mess up. You'd say, well, service department 1 incurred $100,000 of cost. Yes, but they caused $175,000 of cost to be incurred by service department 2. And so this $175,000 right here is literally going to be debited to service department 1 and credited out of the books of service department 2. So now service department 1's costs are not just $100,000, they are $100,000 plus that $175,000 that service department 2 pushed to it. So it's just $275. That's why I highlighted it here, right here in the textbook. And we have to modify the percentages here as well, because water can't flow uphill. We can't push any costs to the top step, to the steps above us. So we have to take this back to 0. And we have to do the same thing we did with the direct method and say, well, we've got to figure out of the work that counts, which is now just these 2, the production department 2, what percent is our work for production department A, and of the work that counts, what percent is our work for production department B. Okay, in short, we end up with the same percentages because we're doing the same thing as in the direct method. That's always true for the bottom step service department, because it will have effectively ignored all interdependencies because they're all up step of it, which is the same thing for the direct method. Just start out by ignoring all the interdependencies. Okay, so now we can take. I just want to reference it. Multiply by those percents. Okay, we got to get that 275,000. We got to get it down to 0. So debit it away from service department 1. Looks like $120,312.50 right here. Same as right there. Is going to production department A, and $154,687.5 is going to production department B. And we check, and yep, we got the full amount there. Okay, so now department A gets 300,000 plus 120,000. Department B gets that 25,000 plus 155,000 effectively. Okay, so these numbers are we're going to compare here for a second. I'm going to hide some things so we can compare them directly. All right, so when we did the step-down method, here's what we got. Department A, $420,000. Department B, basically $180,000. The direct method, we were $80,000 off. So just by incorporating, we have $505,000 to production department A and $94,000, $95,000 rounding to department B. So we have changed that allocation by a significant margin by incorporating a portion of the interdependencies. Okay, I'll unhide the rows here. Yep. B45 right here. Yep. Just taking the original amount for Service Department 1 plus the Service Department 2 cost that got pushed to Service Department 1. I thought that was interesting too. That's why I had it highlighted here in the textbook with so you could see the formula for it. Or I had it selected, I'm saying. Not only did I highlight it, I also selected it. And is that good, Peyton? Yeah. Okay, no problem. I'll also highlight this. So you see that we also did. Yeah, I'll put both of them highlighted. Sure, just copy the textbook completely. There we go. Okay. Yep.
Now, does it work out
you next.
Department A minus Department B equals the cost, or is that just this?
Wait, say that again.
So like for the top step, if you do the 300,000 minus 5,000, you get the same answer. Is that just this scenario, or does it always work out like that, where it's going to be the same value?
That 300,000 minus 25,000 just happens to equal 275,000. Yeah. I don't think it has to be the case. No. Okay. That's just this scenario. It just happens to be equal. Good. You just connecting the dots there, but no, unfortunately, this time I don't think it'll show up in other situations. Okay. Dylan. You want to show the Yes, I took production department A out of the total that counts, which is at this point just the two production departments because it's the bottom step, just like in the direct method. Does that work? Okay. And the same thing over here, just different numerator. Okay. Now, if we had a third one, we were talking about like this middle one. You would say, let's build it real quick, I promise. Let's say, for example, okay, you've got 3 different service departments. This is our up step 1. This is our down step 1. If I could type. Okay, this is a production department. This is a production department. Then you would say, well, we had to zero out the up step 1. And now the ones that count are these right here. Makes sense what I did right there? So it's not necessarily true that it's always just the production departments that count. It's that all the ones that are left are the ones that count. It just happens to line up because we are only doing 2 service departments. So the second one is always the bottom step 1. If we're doing more, you would include every percent that's still there. You zero out the ones that are all up step of you, but you leave in the percentages that are down step of you and leave that in the denominator. All right. If that's confusing to you, it's not any test questions, so we can talk about it after class, I guess. We'll go over it. Okay, so let's do a step down method question. Oh, we can do this. All right, so a firm has 2 service departments, A and B, 2 production departments, X and Y. The firm allocates service department costs using a step-down method, in bold. In the step-down process, department A is first and B is second. Okay, so I told you the order. A is the top step, B is the down step. service department A's services are consumed as follows. And so here in bullet point form, I have given you the rows, the cells in the table. Okay, so A's services are consumed by B 30% of the time, or 30% of its services are consumed by B. 35% of its services are consumed by X. 35% are consumed by Y. And A has $961,985 in cost for the period. Ultimately, I am looking for step down method example problem. A to X. That's what the problem's asking for. Department A to Department X. Okay, now A is the first step. So do we include, do we care, would we allocate to Service Department B for this 30%? I see some nods. Yeah, it's the top step. Everything downstream of it, which includes all the production departments, obviously, they're always at the floor, they're always going to be rained upon, and the downstep service department. So A is at the top, so it's going to move to, so it's got 30% of its cost to Service Department B. Now, it's not directly asking that. But if you zeroed out that and then said, well, 35% of 35 plus 35 is 50%, you would get the wrong answer. So I want to note that we're leaving that 30% in there and just using these percentages as they are because A is the top step. So it's going to include the 30% to B and the 35% to X and the 35% to Y. So we can vary, this is a very simple procedure then. We're just going to take 35% of the number that was given us, of the cost number. It's kind of mean how easy this one is. Now let's try a different way this problem could be phrased. There's another problem, I'm sure. Anyone want to see a cell on that? This one right here is going to be the harder version. Let's go on to the next question. All right, so same setup. A and B are service departments. X and Y are production departments. Step down method. A is first, B is second. Okay, top and bottom step. And I've given you, again, all the percentages in the table, just in bullet point format. And I've given you the costs here. So I've done everything I can to make it harder to copy to Excel. I didn't really mean that, but that is actually what the effect of what I did is. So, example problem 2. Set time method example problem 2. All right, so we want to know, what do we want to know? B to X now. All right. The reason why this is more complicated is that means we also have to solve for A to B. Because this right here, when we're doing the bottom step allocation, which is B is second, it's asking for B's allocation, it's not just its original cost, it's the original cost plus whatever the other service department gave to it. So we've also got to solve for A to B so we can get B to X, the right B to X. So let's work on A to B first. So A's services are consumed, 20% of them are consumed by B. Do we need to reallocate, refigure any percentages? No, it's top step. You just take it as it is. It's got like Easy Town. That was very articulate. It's got like Easy Town. So it's $705,000. It's being Service Department A. Service Department A's $705,000 in cost. Take 20% of that, and it looks like it's that is A to B is $141,111.60. That rounded off a little bit. No, that's even. Okay, good. Now, B's costs are its original costs plus what A debited away to it. Oh, I multiply. The new B costs $706,856.60. Okay. Now we want to know B to X. And so now the question is, Do we use 60%? Oh, good, shaking heads, good. We can't use 60%, right? We've got to do new percentages because we're trying to ignore this 20%. So we've got to say 60% of what? 60% of the work that counts, which is these two right here, 80%. So we need 60% over 80%. Okay, I did the same. I just wrote out here mathematically what I said. 60% over the sum of 60% and 20% gives us now 75%. So 75% of the work that counts was done for Department X. So now this is the B to X allocation. All right, what cells do you want to see again? Yep. I hard-coded it in. I didn't have cells to reference to. It's the same thing as we're doing right here. The percent that we're talking about of the particular department we're allocating to over the sum of the two production departments, which are the only ones that count at that point because it's the bottom step. Okay. So one thing I'll note here, yes, step-down method is less simple and less easy, but if you know what you're looking for and once you get in the habit of these questions, these step-down method questions, there are fewer steps than you might think because you're not doing. I don't have you map the entire allocation situation. Just make sure you know if there are prerequisite allocations, you have to figure out which ones they are. And in this case, we just had two relatively quick, relatively painless, relatively key word there, doing a lot of work in that sentence, two relatively quick and relatively painless calculations to do. So we can manage this, right? If your answer is no to that, I have nothing to offer you, but the hope that perhaps in time the answer will be yes. Okay, so let's talk about the reciprocal method because that's all we have to do is talk about it. This right here almost certainly is a question that doesn't say it in the question stem, but it really is about the reciprocal method. So we'll come back to that in a minute. I want a new sheet for this. So the reciprocal method can be thought of in two different ways, either algebraically or through brute force. So we'll show how both answers are the same, end up with the same thing. I think it's the algebra spelled out okay here. I'll just go through the lines. Maybe zoom in. No, that didn't work. So the first thing we have to do, which is sometimes the step where people get themselves reversed in what they're doing, is state the identities. We need a system of equations that we're going to solve for. So the actual, all right, let me step back for a second. What we're trying to solve for is the allocation basis. If you go back up to the step-down method, maybe you noticed that we ended up with a bunch of cost over here in Service Department 1. We ended up with, if you took, I guess what I'm trying to say is we took all the debits in this allocation system, they would equal more than $600,000 because some of them are going between service departments. There's some money flying around that eventually gets resolved. All of it settles in the end in production departments as just $600,000. But there's some debits that are thrown around between service departments that are offset by credits. So the net of them in the end equals $600,000. So what we're trying to solve for is what are called the allocation bases. What number could we put in SD1 and in SD2, the cost right here, where if we multiply them by these percentages, we get exactly 60,000 allocated at the end to the production departments and exactly the right amount allocated to each other that get canceled out to zero. That's what we're solving for. The exact number to change these highlighted cells to, so that these numbers cancel each other out. Because look, we solved for, and we got 59,140 from Service Department 1 to Service Department 2. Guess what? 2 happens to be, its allocation base is its original 500,000 plus 59,140. So that cancels out exactly. And 2 is allocating to 1, 195,699. That happens to be the exact amount over its original 100,000 that Service Department 1 is. So we want these two numbers that make everything cancel out just right and maintain the original percentages and the entire interdependency. We're going to maintain all the interdependency. We're going to solve for the right number. Where do the lines cross? That's what we're doing here. So we have to state the identities mathematically. So SD1 is going to equal its original 100,000 right here, plus the 35% of SD2's work that it consumed. So 0.35 of whatever SD2 is. Now SD2 is defined as its original 500,000 plus 20%. It's 20% of SD1's work. So we can take SD1, this equation right here, and replace this term SD2 with the expanded term 500,000 plus 0.2 SD1. That's what I did right here in these brackets. So this first line here is just a restatement of this original equation, this top equation right here, but with SD2 replaced by the bottom equation right here. So this side of the equal sign anyway of the bottom equation. All right, and you solve it through and you end up with SD1 equals 295,699, which is right here. And then you can take that amount. Now you have a dollar amount, so it's even easier, and you can plug that in for where it's at SD1 on this equation right here. So we have 500,000 plus 0.2, that matches this right here. And SD1, we're going to plug in the 295,699, which we solved for in the first step here. And we end up at the end with SD2 equals 559,140. Okay, you plug in those two allocation bases, you multiply them. Here, we will do that now. Same core fact pattern as before, so we can copy that over. But now we're saying, let's plug in these allocation bases, 295,699 and 559,140. And we're going to multiply every single cell by its actual percent. We haven't zeroed out any cells. No percentage has been zeroed out. But we're multiplying by these mathematically determined allocation bases, which should make everything cancel out just right. Okay, we've allocated all the money here. That's what these tell us. And all the money here. Good. I want some. Okay. Looks like it all works the same. All right, now I want to take some numbers here. Okay, I pasted the values here. When we did it with the direct method, we allocated to Production Department A $505,000 and Production Department B $94,007. When we did the step-down method, we reduced that by quite a bit. Production Department A, only $420,000 being allocated to Production Department A, $180,000 rounding to Production Department B. And when we do the reciprocal method, which incorporates all of the interdependency, it's in between those two actually. $438,978 to Production Department A, to Production Department A, and $161,021 to Production Department B, which ends up being almost exactly 600,000, which is the amount we were looking for. The difference is due to rounding. I rounded these a little bit. That extra 20 cents. Okay, so it's how we cut the pie up. Yeah. It's not saying these numbers match. It's saying that we could we could do this allocation first for service department 1, and then this one, or vice versa, and we would get the same number here, is the idea. And that's true for the reciprocal method. It's also true for the direct method, right here. We could multiply that 500,000 by these percents first, or we can multiply the 100,000 by these percents first, and we would get the same thing. The problem is the step-down method. It does not follow that rule. So the answer is going to be the direct and reciprocal, whichever answer says direct and reciprocal for that one. The step-down method order does matter. That's why I have to tell you in the question, A is first, B is second, or B is first, A is second, because I have to tell you, because otherwise you will get a different answer. Does that make sense? But yeah, no, your point about they differ between methods, that is true. They definitely do differ between methods. And that's why reciprocal gets the remaining spot here. It's going to be the most accurate, but it's the least, and it's the least simple, the most complex, reciprocal, and hardest to trace what's happening and explain. So the other thing I want to point out is we actually could get here by brute force, the reciprocal method. Before we go too much further about how to answer the conceptual questions about reciprocal method, most of them actually are answered, a large number of them are answered by simply knowing this ranking of the three methods. This is a raw every semester, and I've got to think through exactly how I'm doing it. Okay, I'm getting there. Just give me a second. No, I don't know how I got so. Recently, I have been really missing Control C for Control X. I don't. My finger got shorter or something. I don't know what's happened. Yes, that's what I want to do. This. Okay, so here's what I'm doing. So if we just started by not ignoring any interdependencies, and we're just going to keep allocating all the cost out of service departments over and over and over and over and over again until we have none left, because eventually they will drain out. You get smaller and smaller pieces of the pie. That's what we're going to do. And we make sure that they accept whatever cost they've been given. Okay, I'm just taking the original 500,000 plus, looks like SD1 pushed $20,000 over to us. So now SD2 has $520,000. No, excuse me. These get smaller and smaller. So it's going to be just the amount that was pushed over because we credited out the 500,000. There we go. Now we're going to get this right. All right, so excuse me. So we start out, SD1 credited out all $100,000 of it, pushed $20,000 to SD2, $35,000 to PD $45,000 to PDB, but it received $175,000. So now after the first round of allocations, it has $175,000 in it. Service number 2 started with $500,000 and pushed all $500,000 out, credited that amount, but now it has a debit of $20,000 heading its way. So in the second round, we start with SD1 $175,000, SD2 $20,000 to say it right. We multiply that again. We do that again. Looks like SD1 has 7,000 now. SD2 has 35,000. Let's repeat this process for a fourth time. It's getting smaller and smaller, right? I promised you. 12,250, 1,400. Let's just keep going it. I'll stop narrating. Down to the cents. And this is where I'll stop. And now, the sum of the allocations to our production departments once I get it all done. Ooh. Okay. I'm trying to ignore the percents that I kept copying over for simplicity here. All right, once I sum every time we allocated how much went to a production department, in the process of the two service departments passing a bunch of costs back and forth until it gets to nothing basically being allocated between the two, we end up with the exact same amount that we algebraically figured out, or we would with rounding. Okay, so by brute force, we basically have said, let's just keep allocating until we have nothing left to debit to each other. And eventually they will drain out of the service departments. People, the economists and the thinkers and people who theorize all this stuff are like, but this is so much cleaner and nicer. It's the same thing in the end. If you but yeah, the idea is we have, or rather, they both follow the idea that we have incorporated all the interdependency this way through many rounds. Looks like we probably allocated almost sell 100, so probably allocated 10 times, 15 times. Yeah, good number of times. Maybe upwards of 20, because I think there are 5 rows in each time I copied it. I skipped one too, so I don't know, 15, 20 maybe. I don't know if I was going to finish that sentence I started, but that's the idea. So let's look up this question here and any other conceptual questions we can come up with here. So, which of the following is false about service department cost allocations? All right. So we want to rule out anyone that is true, right? So let's see which ones are true, and then we can say, nope, not that one. The step-down method is more accurate than the direct method, assuming interdependency among service departments. So yeah, once there's interdependency, let me say this as a statement, because I don't think I covered that before. The accuracy here only happens when there's interdependency. If service departments didn't serve each other at all, you're going to get the same number for all 3 methods. They have no way of differing. There's nothing that would differ. They all start with zeros in the interdependency cells, like the direct method. Okay, so once there's interdependency, they have this stratification of accuracy. And so that's what that part of the statement is saying. So, well, assuming there's interdependency, step-down method is more accurate, which is true, right? It's number 2, direct method is number 3, so it's higher in accuracy. The reciprocal method is the most accurate, again, assuming interdependency. Yep, it's number 1 on the method. So that's true, which means it can't be the answer to which one's false. The reciprocal method is often harder to explain to managers, assuming interdependency among service departments, and is at least slightly harder to execute. So that's what I mean when I say over here that it's the least in simplicity, at least marginally harder to execute. And the other big cost is it is harder to rationally explain, because maths. Yeah, nobody wants to hear, why didn't I get my bonus today or this month or whatever? The accountant come back and say, well, because of algebra. So it's a little harder to trace exactly where the things are going. Yeah.
So then if the question were to ask a firm's 2 production departments and 2 service departments, which would fall strip out the service department cost allocations, then it would be the direct method is the least accurate.
That is true, yeah. Does it say assuming interdependency or whatever?
Yeah, but the difference between, is there 2 of them that the direct method is the least accurate, but the difference is that one of them says production, the other says service. So service.
You're saying the B versus D here, and the difference there is the production. Yes. Because the service department serving each other is what is interdependency as far as we're concerned for chapter 10 here. Yeah. All right, and so we're left with the last one being false. Service department cost allocations are simpler when there is interdependency among service departments. No, that's what causes the whole problem. If these cells right here were zeros all the time, no interdependency, no service departments serving each other, then it would just take the whatever number is the cost number times the percent and go home. That's it. Don't have to stay late during close. Okay, have any other reciprocal questions? No. I do have a couple here. I skipped over them, which don't ask you to do much. Just say, convert this into a percent. So in this case, what percentage of maintenance department labor hours are consumed by the power department? So maintenance hours consumed by the power department, what percent? 250 out of, looks like that sums to 500. So it should be 50%. Yeah, there's some micro step ones in here. And you're like, I know right now you're like, okay, what black magic can I use so that is the question that gets pulled on the final exam from this test bank? And I don't know the answer to that question. I'm sorry. I don't have any special voodoo for you. But they are little micro step ones. So if you know how to do that, but you've forgotten other things, you can still get points for that level of knowledge. Okay, anything else you want to talk about? No. Other questions you have before we're done today? Yeah, and then LT after.
For the final note card, is there
Page.
like not like the page, but like what's on there? Is there a limit to it? What can or can't be on there?
No, you a limit like.
Hypothetically, like if I typed it up and I would screenshot the question, can I do that? Like if I can fit it?
I haven't disallowed that.
Okay.
I'm pretty confident that the test bank's robust enough that you'll run out of space before you can do that. Or eyesight. You'll run out of space or eyesight. Those two limiting factors, I think, limit that to a degree. And there's also the fact that the limitation to that is we're talking about 25 questions out of a large test bank. Very likely that the majority of your notes then would be wasted space, is the problem with that. If there is a particular type of question, you're like, this is really emblematic, I could see it being worthwhile to be like, hey, here's this question, here's what we do with it. And then it serves multiple purposes. That helps you with that question, and it helps you with other questions like it, or the general topic. It reminds you, it can be a memory kludge to help you remember other things from that chapter or whatever. I can see that being worthwhile. But no, I haven't. I've left it open. I still feel pretty confident in the integrity of the exam with leaving it open to whatever you want on the page there. Yeah, you can.
Is it
Yeah.
front and back or just
Front and back. Yeah, you can do front and back. Yeah. Elton, yeah.
So are we going to learn? Is there a reciprocal method?
Oh, good question. You don't have to do it. No, there are some conceptual questions that say where you have to know that it's the hardest to explain but the most accurate, but you don't have to execute it. No. I know, huh? No. I made that choice because I know in my undergrad we didn't do the reciprocal. It didn't happen until I took a graduate cost accounting class. So I figured, well, that's decent way to break it up. It's fine. But you've learned about it now, and you know the characteristics of it, and there are some conceptual questions that test you on the characteristics of it. Yeah.
My question might be answered, but I haven't taken the quiz yet. But I'm wondering if there is once submitted explanation.
I don't think it gives an explanation. There are a few questions that have feedback on them with an explanation in the test bank in general. Huh?
Is there a way you can set it up to give the explanation for the
I can't in the time frame we're talking about. That is a project that's ongoing because that I have to manually put the feedback in for each question in the test bank. It's occasionally I've done that, but it's been pretty rare. I would say it's pretty rare. It's a small percentage of the questions. You might have seen them before. You see some questions where you look and here's the ones that are wrong, or when you look at your quiz afterwards, there might be a note underneath it that says something. Maybe you've seen it or not. There are a few of them that have that, but it's a pretty small percentage of the test bank. What I would suggest is if there are ones you can't figure out on its face, just shoot me an email real quick. Just screenshot it, shoot me an email. I'm happy to get to say why it was wrong or what to improve upon. Yeah. it's a suboptimal solution. I want to automate that so it does exactly what you're saying, but I haven't done it yet. And it's a good number of hours that we require to do it. Yeah.
But now you get questions. So it's not like a
Yeah. Gotcha. Yeah. Oh, okay. Yeah.
Is it the review quiz exactly how our quizzes are now, where like after we take it to do the new test, we don't know the answers? Like it doesn't say like correct answer. Like it just says if it's wrong.
Oh, I think it has the same programming. Yes. Yes. Yeah. Okay. Well, I'll see you Thursday. We'll go over more questions here and talk about what the last part of chapter 2, 10-2. Start the theory there.